Welcome to Module 2. This module aims to provide an overview of IMO's energy efficiency regulations for ships and their related guidelines. The module describes Chapter 4 of MARPO Annex 6 in detail and then explains the following: the EEDI, or Energy Efficiency Design Index, the SEEMP, or Ship Energy Efficiency Management Plan, and the EEOI Energy Efficiency Operational Indicator, as well as their relevant IMO guidelines. Upon completion of this module, you will be able to do the following: name and explain energy efficiency related MARPO Annex 6 regulations. Describe the concepts of attained EEDI, required EEDI, reference lines, and reduction factors, and how they are related to each other. Calculate attained EEDI and required EEDI using ship data. Describe the main aspects of EEDI survey and verification and the relevant processes and organizations that are involved. Describe the main features of a SEEMP according to relevant guidelines. Calculate EEOI using relevant data for a ship, and identify related guidelines and why they have been developed, as well as explaining their usage. A number of topics are covered in this module. They include the IMO Regulatory Framework for Ship Energy Efficiency, or SEE, MARPO Annex 6, Chapter 4 Regulations, Guidelines, Development of Sea Management Plan, SEEMP, Guidelines for the Calculation of EE Operational Indicators, EEOI. The time chart on this slide summarizes the activities that led to the adoption of Chapter 4 of MARPO Annex 6 on energy efficiency for ships. This chart and a detailed chronological account are covered in Module 3 and so are not further developed in this module. Instead, Module 2 focuses on the resultant IMO regulations and guidelines. Let us look at these now. Chapter 4 of MARPO Annex 6 introduces two mandatory mechanisms as energy efficiency standards for ships. The main objective of these standards is to reduce GHG emissions of international shipping through improved ship design and operations. These regulatory mechanisms are the Energy Efficiency Design Index for new ships, EEDI, and the Ship Energy Efficiency Management Plan for all ships, SEEMP. EEDI. The EEDI is an index that indicates energy efficiency of a ship in terms of GCO2 generated per ton, mile cargo carried for a specific reference ship operation condition. The intention is that by imposing limits on this index, IMO were to drive a ship's technologies to be more energy efficient over time. EEDI is thus a goal-based technical standard that is applicable to new ships. Ship designers and builders are free to choose the technologies that meet the EEDI requirements in a specific ship design. Over time, the EEDI level will be reduced and will gradually lead to more energy efficient ships. SEEMP. SEEMP is a management tool that establishes a mechanism for ship operators to improve the energy efficiency of a ship during its operational lifespan. It works according to the cycle of continuous improvement of planning, implementing, monitoring, and reviewing of a number of energy efficiency measures. The IMO SEE framework or Ship Energy Efficiency Framework, is a regulatory framework that incorporates a number of measures for ship owners or operators. These include the SEEMP, the Ship Energy Efficiency Management Plan, the EEOI, the Energy Efficiency Operational Indicator, and the EEDI, which is the Shipyard Design and Construct, or EE Design Index. These will be discussed in detail in later modules. Chapter 4 of MARPOL introduces two mandatory mechanisms as energy efficiency standards for ships. The primary objective of these standards is to reduce the GHG emissions of international shipping through improved ship design and operations. These two regulatory mechanisms are the EEDI, Energy Efficiency Design Index for new ships, the SEEMP, the Ship Energy Efficiency Management Plan for all ships. EEDI. This is an index that indicates the energy efficiency of a ship in terms of CO2 generated per ton mile, and that it's calculated for a specific reference ship operational condition. The intention is that by imposing limits on this index, the IMO will be able to drive ship technologies towards more energy efficient ones over time. The EEDI is thus a goal-based technical standard that is applicable to new ships. Ship designers and builders are free to choose the technologies to satisfy the EED requirements in a specific ship design. Over time, the EEDI level will be reduced, so gradually leading to more energy-efficient ships. The SEEMP is a management tool and establishes a mechanism for ship operators to improve the energy efficiency of ships during their operational life cycle. SEEMP follows the steps of a continuous improvement management cycle. This is planning, implementation, monitoring, and review of energy efficient measures. The EEOI, or Energy Efficiency Indicator. Additionally, IMO has adopted a voluntary scheme for the calculation of energy efficiency, the EEOI. The main objective of this measure is its potential use as a monitoring performance indicator in shipping, most likely in relation to SEEMP. The diagram on your slide illustrates how the three measures will work together to cover both ship design and ship operation. Following a significant debate at IMO on ship energy efficiency regulations, major new amendments to MARPOL Annex 6 were adopted in July of 2011, MEPC Resolution 203-62. As a result, some of their existing regulations were updated, and a set of new regulations was added. The table on the slide summarizes the existing regulations in Chapter 1 and 2 of MARPOL Annex 6, and the ones that were changed, which are indicated in red, to accommodate the energy efficiency regulations. Regulation 2.23 clarifies the definition of a new ship. New ship means a ship for which the building contract is placed on or after the 1st of January 2013, or, in the absence of a building contract, the keel of which is laid or which is at a similar stage of construction on or after the 1st of July 2013, or the delivery of which is on or after 1st of July 2015. Major conversion means, in relation to Chapter 4, a conversion of a ship which substantially alters the dimensions, carrying capacity, or engine power of the ship, or which changes the type of the ship, or the intent of which, in the opinion of the administration, is substantially to prolong the life of the ship, or which otherwise so alters the ship that if it were a new ship, it would become subject to relevant provisions and conventions that are not applicable to it as an existing ship, or which substantially alters the energy efficiency of the ship and includes any modifications that could cause the ship to exceed the applicable required EEDI as set out in Regulation 21. Some ship types, for example shipping vessels, are not yet part of the EEDI regulations. The following list provides the ship types that are currently required to comply with attained EEDI regulation. They are 2.25 bulk carrier, 2.26 gas carrier, 2.27 tanker, 2.28 container ship, 2.29 general cargo ship, 2.30 refrigerated cargo ship, 2.31 combination carrier, 2.32 passenger ship, 2.33 ro-ro cargo ships or vehicle carriers, 2.34 ro-ro cargo ships, 2.35 ro-ro passenger ship, 2.38 LNG carrier, 2.39 cruise passenger ships. A number of other clarifications are made under Regulation 2, icebreaking cargo ships, conventional and non-conventional propulsions. Ships in Chapter 4 are also required to be subject to the surveys as below. An initial survey before a new ship is put into service, a general or partial survey after a major conversion of a ship to ensure that the attained EEDI is recalculated as necessary. For major conversions regarded as a newly constructed ship, the administration shall decide the necessity of an initial survey. For existing ships, the verification having a SEEMP on board shall take place at the first intermediate or renewal survey, whichever is the first, on or after the 1st of January 2013. The survey and verification for EEDI shall be done according to IMO's EEDI Survey and Verification Guidelines. An IEE certificate needs to be issued to any ship of 400 gross tonnage and above before that ship may engage in voyages to ports or offshore terminals under the jurisdiction of other parties. The certificate must be issued or endorsed either by the administration or any organization duly authorized by it. No IAPP, International Air Pollution Prevention Certificate, or IEE certificate may be issued to a ship which is entitled to fly the flag of a state which is not a party. Regulation 7. The IEE certificate will be drawn up in a form corresponding to the model given in Appendix 8 to this Annex. Regulation 8. The IEEC shall be valid throughout the life of the ship, subject to the provisions of paragraph 11 below. Paragraph 11. An IEEC issued under this Annex shall cease to be valid in any of the following cases: if the ship is withdrawn from service, or if a new certificate is issued following major conversion of the ship, or upon transfer of the ship to the flag of another state. Article 5. Certificates and special rules on the inspection of ships. 1. Subject to the provisions of paragraph 2 of the present article, a certificate that is issued under the authority of a party to the Convention in accordance with the provisions of the regulations will be accepted by the other parties and regarded for all purposes by the present convention as having the same validity as a certificate that they themselves issued. 2. A ship that is required to hold a certificate in accordance with the provisions of the regulations is subject, while in the ports of offshore terminals under the jurisdiction of a party, to inspection by officers who have been duly authorized by that party. Such inspection is limited to verifying that there's a valid certificate on board, unless there are clear grounds for believing that the condition of the ship or its equipment does not correspond substantially with the particulars of that certificate. In such an instance, or if the ship does not carry a valid certificate, the party carrying out the inspection will take such steps needed to ensure that the ship will not sail until it can proceed to sea without presenting undue harm to the marine environment. That party may, however, grant such a ship permission to leave the port or offshore terminal for the purpose of proceeding to the nearest appropriate repair yard that is available. As a result of energy efficiency debate at the IMO and subsequent agreements, a new Chapter 4 was added to MARPO Annex 6. The table below indicates in red the new regulations that have been added. In the next few slides, a short description of the main aspects of these regulations will be provided. This regulation specifies the domain of application of the energy efficiency regulations. Accordingly, Chapter 4 of MARPO Annex 4 applies to all ships of 400 gross tonnage and above that are engaged in international waters. It gives limited power to administrators to waive the requirements for Energy Efficient Design Index, or EEDI, for a new ship up to a delivery date of 1st of July 2019, subject to informing the IMO and other parties to MARPO Annex 4 of this decision. Regulations 20 and 21 do not apply to ships which have non-conventional propulsion. This is with the exception of cruise passenger ships and LNG carriers having conventional or non-conventional propulsion and that are delivered on or after the 1st of September 2019. The administration may waive the requirement for a ship from complying with Regulation 20 and Regulation 21. The provision of the above shall not apply to ships with the following: contract date 1st of January 2017, keel laying date 1st of July 2017, delivery date 1st of July 2019. The above implies that waiver is only for 4 years. The administration of a party which allows application of waiver to a ship shall communicate this to the organization for circulation to the parties. This regulation deals with the attained EEDI and specifies the need for its calculation and verification. Attained EEDI is the actual EEDI of a ship as calculated using the EEDI formula. According to this regulation, the attained EEDI must be calculated for the following: each new ship which undergoes a major conversion, or an existing ship that undergoes so many changes as, according to judgment by administration, can be considered as a new ship. The attained EEDI is applicable to a large number of ship types, but not all ships. For example, fishing vessels are not required to have an attained EEDI. The attained EEDI must be calculated taking into account relevant IMO guidelines. The attained EEDI must be accompanied by an EEDI technical file that contains the information necessary for the calculation of the attained EEDI and that shows the process of calculation. The attained EEDI must be verified based on the EEDI technical file, either by the administration or by any organization duly authorized by it. This regulation specifies the methodology for calculation of the required EEDI and all relevant details. The required EEDI is the regulatory limit for EEDI, and its calculation involves the use of reference lines and reduction factors. The basic concepts included in this regulation are as follows. Reference line. This is a baseline EEDI for each type, representing reference EEDI as a function of the ship size. Reduction factor. This represents the percentage points for EEDI reduction relative to the reference line as mandated by regulations for future years. This factor is used to tighten the EEDI regulations in phases over time by increasing the value. Cut-off levels. Smaller size vessels are excluded from having a required EEDI for some technical reasons. Thus, the regulatory text specifies size limits. The size limit is referred to as a cut-off level. Implementation phases. There are 3 phases for the implementation of EEDI. They are Phase 1 from year 2015 to 2019, Phase 2 from year 2020 to 2024, and Phase 3 from 2025 onwards. Reference lines are ship-specific and depend on ship type and size. The full details of how reference lines are developed, including sources of data, data quality checks, number of ships selected and year of build, ship sizes, and so forth, are fully described in the relevant IMO guidelines. See Resolution MEPC 231/65 and Resolution MEPC 233/65. Parameters A, B, and C for some of the ship types are given in the table. B is ship capacity. A and C are constants agreed for each ship type and included in the regulation. Reference EEDI, reference value for EEDI. The Pacific Community, SPC, Pacific Island Domestic Ship Safety, PIDSS program, developed the Safe Operating Plan, or SOP, that forms part of a safety management system for domestic ships. The SEEMP is only introduced by MTCC Pacific under the umbrella of the PIDSS for safety reasons. By now, all ships should have a SEEMP on board. Resolution MEPC 245/66, 2014 guidelines on the method of calculation of the attained EEDI for new ships was adopted on the 4th of April 2014. The attained EEDI is the actual value of EEDI for a ship and represents the amount of CO2 generated by a ship while doing 1 ton-mile of transport work. In simple terms, it may be represented by the equation in the slide. It is argued that EEDI represents the ratio of a ship's cost to society in the form of its CO2 emissions divided by its benefit to the society, which is represented by the transport work done by the ship, as shown in the slide below. The above concept then translated into a more vigorous calculation method, as represented by EED formulae in equation 2 in the next slide, to account for diversity of ship types, ship sizes, alternative propulsion technologies, alternative fuels, and future renewable technologies. Attained EEDI is calculated using the EEDI formula as shown in the slide below. According to MARPOL Annex 6 Regulation 22, it is a requirement for ships of more than 400 gross tonnage operating internationally to have a ship energy efficiency management plan on board from the 1st of January 2013. The SEEMP should be developed taking into account the IMO guidelines. Existing ships will receive an International Energy Efficiency Certificate when it is verified that there is an SEEMP on board. This will happen at the first intermediate or renewal survey of the vessel after 1st of January 2013, whichever is the first. It is expected that by now all existing ships will have gone through this process and possess an IEEE certificate. The purpose of a SEEMP is to establish a mechanism for a company and/or ship to improve the energy efficiency of the ship during its operation. Preferably, the ship-specific SEEMP is linked to a broader corporate energy management system of the company that owns, operates, or controls the ship. The ship-specific SEEMP is needed since no two shipping companies or ship owners are the same, and ships operate under a wide range of different conditions, including geographical and commercial differences. SEEMP should be developed as a ship-specific plan by the company. SEEMP should be adjusted to the characteristics and needs of individual companies and ships. It is recommended that a company also establish a SEEMP to improve fleet energy performance and stakeholder coordination. The SEEMP works through 4 steps. The steps are planning, implementation, monitoring, and self-evaluation. These 4 components play a critical role in the continuous cycle to improve ship energy management. Planning is the most crucial stage of SEEMP. Planning primarily determines both the current status of ship energy usage, the baseline, and the expected improvement. Consequently, it is important to devote sufficient time to planning. The identification of ship-specific energy efficiency measures needs to recognize that there are a variety of options to improve ship energy efficiency, that the best measures differ to a large extent for ship type, cargo, route, and other factors, and that specific measures to improve SEE should be identified in the first place. After identification of the SEE measures, these should be listed as a package for implementation. The improvement of ship energy efficiency does not only depend on ship management. A number of stakeholders involved, and the more coordination there is between the stakeholders, the more rewarding it is. The company should do the coordination rather than the ship. A company energy management plan is recommended to manage the fleet and facilitate stakeholders' coordination. Raising awareness and providing necessary training for personnel both onshore and on board are an important element. This HR development is encouraged and should be considered as a key component of planning as well as a critical element during implementation. Goal setting is part of planning. Goal settings are voluntary, and there is no need for an announcement to the public, nor are they subject to external inspection. The purpose of goal setting is to increase commitment to improving energy efficiency. The goal can take any form, such as annual fuel consumption or EEOI targets. A goal needs to be measurable and easy to understand. A system for implementation of the selected measures should be completed by developing the procedures, tasks, and responsibilities that are required. The SEEMP should describe how each measure should be implemented, who is responsible, the implementation period of each selected measure. The development of such a system can be considered as part of planning and therefore may be completed at the planning stage. The plan measures should be implemented in accordance with the predetermined EnMS. Record keeping for the implementation of each measure is necessary for self-evaluation. If any identified measure cannot be implemented for any reason, the reasons should be recorded for internal use. Consistent data collection is the foundation of monitoring. The monitoring system, including the procedures for collecting data and the assignment of responsible personnel, should be well developed. The development of such a system can be considered as part of planning and therefore should be completed at the planning stage. To avoid burdens on ship staff, monitoring should be carried out as far as possible by shore staff. Self-evaluation and improvement is the final phase of the management cycle. This phase should produce meaningful feedback for the next improvement cycle. The purpose of self-evaluation is to evaluate the effectiveness of the planned and implemented measures. For this process, procedures for self-evaluation of SEE measures should be developed. Furthermore, self-evaluation should be implemented periodically by using data collected through the monitoring process. In summary, the SEEMP will, as a minimum, include the following components: ship identification details, energy efficiency measures and how they should be implemented, responsible persons and timeline, monitoring aspects, goals, that's optional, evaluation aspects. The SEEMP framework is based on the Plan, Do, Check, Act continuous improvement cycle. When developing SEEMP, all the above elements need to be defined at the planning phase. At its core, the SEEMP has a number of EE measures together with implementation methods, monitoring and checking, self-assessment, roles and responsibility, processes and procedures. Thank you. This slide completes the current module.